Okay, trigonometry review. So question number 1, measure a triangle with a ruler and a protractor and confirm with Pythagoras' theorem. So if we take our ruler out and we measure the bottom length, we're going to get 3 centimeters. And then if we measure the vertical length, we're going to get 2 centimeters. And if we measure the diagonal, we're going to get approximately 3.6 centimeters. Now we have angles, and if we measure the angle on the bottom left with a protractor, we're going to get approximately 34 degrees, and we obviously have a 90. And then if we measure the top right angle with a protractor, we're going to get approximately 56 degrees. So this should all make sense. Let's check with Pythag. So a squared plus b squared equals c squared. So 3 squared plus 2 squared equals 3.6 squared. So 3 squared is 9, and 2 squared is 4, and 9 plus 4 is 13, and 3.6 squared is 12.96. Incredibly accurate. Now let's check it with all sorts of trigonometry. So let's start off with tan theta. So let's go for tan theta equals opposite over adjacent. If you forget, remember SOHCAHTOA. SOHCAHTOA. Tan is the opposite over the adjacent. So if we take the angle 34 degrees, tan 34 equals opposite. The opposite of the 34 is going to be 2 centimeters, so 2 over, and the adjacent is 3. Now if I check on my calculator, the tan of 34 is equal to 0.67, and 2 divided by 3 is equal to 0.6 repeater. Incredibly accurate, so we know we're absolutely correct. So don't forget that you can always just draw the triangle with all the appropriate measurements and check with Pythagoras' theorem and trigonometry to make sure that we know it's correct. Okay, number 2. So it says find sine theta of a triangle, of a right angle triangle with side lengths of 5 and 2. I don't really care about the size. We know we have a right angle. Again, the actual scale is not going to matter. They want to identify theta in the bottom left-hand corner. So it says find sine of theta. So we know that sine of theta is equal to the opposite over the hypotenuse. So the opposite of the angle is opposite of the angle, and the hypotenuse is on the hypotenuse. So we can then therefore say sine theta is equal to opposite 2 over hypotenuse. We don't have the hypotenuse. How are we going to find that? Well, we're going to have to use Pythagoras' theorem. A squared plus b squared equals c squared. So if we substitute into the equation, 5 squared plus 2 squared equals c squared. And 5 squared is 25, and 2 squared is 4. Therefore, 25 plus 4 is 29 equals c squared. And in order to cancel the squared, we must square root both sides, and c will therefore equal root 29. We can circle our answer, and we can put that in the diagram. Square root 29. You can also find out what square root 29 is. I'm going to circle it in the diagram as it's found information. You can find out that the square root of 29 is approximately 5 point something, but good enough. So sine theta equals 2 over root 29. And that is the answer. That is what sine theta equals to. So in the previous question, for example, sometimes we have to type in something like tan of 34 and figure out what it is. But in this one, we just figure out what sine theta is and give the ratio of the opposite side over the hypotenuse side. Okay, so number 3. Solve on the calculator to 3 decimal places. So we have tan 25 equals. So on the calculator, we're just going to type tan 25, and we're going to get 0.466 rounded to 3 decimal places. So we're going to circle our answer. Okay, 10 tan 30. So 10 sine 30 equals. So on the calculator, we're just going to press 10 sine 30, and we're going to get 5. So again, remember, sometimes we're just typing into the calculator. Lots of the times we have to type into the calculator for further algebraic steps, and these are just the introductions to those steps. All right, number 4. So we have a triangle to be drawn. We have a right angle triangle with an angle of 30 degrees and a hypotenuse of 10. So we want to choose, it says solve for the opposite, adjacent, and other angle with trigonometry. So we have to basically solve for everything. So let me put my right angle in there. So what do we want to find first? Well, let's find the opposite first, OPP. And then we'll find the adjacent later. So in order to find the opposite, we want to use the part of SOHCAHTOA that has 2 pieces of information that we have and 1 that we're looking for. So if we're looking for the opposite and we have the hypotenuse, that means we have to use sine. So we can start by saying sine theta equals opposite over hypotenuse. Now we know our angle is 30, so we can say sine 30 equals the opposite, we don't know, over 10, the hypotenuse. And when something's on the bottom, we simply times both sides by that thing. 10 times 10. And 10 over 10 is 1, so that's get crossed off. Therefore, we know that the opposite is equal to 10 sine 30. So on the calculator, 10 sine 30, just like we did before, and the opposite is therefore equal to 5. I'm going to circle my answer, and I'm going to put that answer in the diagram, and again, circle my answer. So we found the opposite. Now we could use Pythag to find the adjacent, but we're going to use trig, and then we're going to check our answer. So because the 5 could be rounded, we're going to use the hypotenuse again, and if we want the adjacent, we're going to use cos. So let's say cos theta equals adjacent over hypotenuse. So again, we can use the angle 30. So cos 30 equals the adjacent, we don't know, ADJ, over the hypotenuse, 10. And again, we're going to simply times both sides by 10, 10 times, and times 10. The 10's cross, and on the calculator, we're going to type 10 cos 30 this time, and we're going to get the adjacent equaling 8.66. We can put that in the diagram, 8.66, and we can circle our answer. So before we find the other angle, let's use Pythagoras to check our answer. A squared plus b squared equals c squared. So a squared, 8.66 squared, b squared, 5 squared, equals the hypotenuse, 10 squared. So on the calculator, 8.66 squared plus 5 squared is equal to 100. And 10 squared on the right-hand side is also equal to 100. Therefore, we are correct, and we have done it correctly. So now we need to find the other angle. So we could obviously do 90 minus 30 and get 60, but let's use it doing trig. Now we haven't used tan yet, so let's use tan just for fun. So tan theta equals SOHCAHTOA, adjacent, over hypotenuse. So we have 30 degrees. We're looking for theta. Excuse me, right. So now let's use tan theta. We're looking for the other angle. So I'm going to identify theta in the diagram in red. Now notice the adjacent and the opposite switch. So I'm going to cross at ADJ. I'm going to cross at OPP. I'm going to switch them. So now the opposite is OPP and the adjacent is ADJ. Notice they switch. Therefore, tan theta is now equal to the adjacent 5 over the, whoops, I wrote hypotenuse. Notice I wrote hypotenuse. I'm going to cross it out in red and write it. Opposite over adjacent. Notice I just did cos. So I was thinking, oh yeah, I made a mistake. That's going to happen all the time. The definition of tan theta from SOHCAHTOA at the top is opposite over adjacent. So be really careful with SOHCAHTOA. It's very easy to make those mistakes. So now I have to redo 5 over. So my opposite is therefore 8.66. And my adjacent is therefore 5. Now I'm going to find theta by simply doing theta equals tan -1 open bracket 8.66 over 5. So on the calculator, if I do second tan 8.66 divided by 5, I'm going to get theta equals 59.99 degrees, 99 degrees, which is essentially 60. So we know that the angle in the diagram theta, I'm going to put an arrow to it, is 60 degrees. And circle our answer as we expected. Now I'm going to check my answer to make sure that all the angles add up to 180 degrees. So 30 plus 60 plus 90 equals 180 degrees. Notice I could have done that instead of using trig. Keep in mind you can use either sine, cos, or tan to find the angle. It won't matter as long as you use the appropriate SOHCAHTOA. And again, be very careful with SOHCAHTOA at the top right. Notice I made a mistake. That's going to happen. Notice I crossed it out in red and corrected it to show that I'm going to be much more aware of the mistakes that I make in the future. Crossing things out in red pen, much more easily allowing to see the mistakes that you do. Okay, number 5. So we have a right angle triangle, obviously, with an angle of 60 degrees and a side of 12. So it says solve for the hypotenuse, opposite, and other angle with trig. So let's start by labeling our triangle. So we have the opposite of the angle being OPP. We have the hypotenuse, HYP, and we have the adjacent, ADJ. So again, let's start off by finding the opposite, but let's use tan this time for fun. So let's write down the definition. Tan theta equals opposite over adjacent. SOHCAHTOA, opposite over adjacent. TOA, opposite over adjacent. TOA, making sure I do that correctly this time. Therefore, tan 60 equals the opposite, OPP, we don't have, over the adjacent, 12. So now I'm going to multiply both sides by 12 to cross that 12 off. 12 times 12. 12 over 12 is 1. Therefore, the opposite is equal to, on the calculator, 12 tan 60 equals 20.8. We can put that in the diagram, circle our answer. We can put that in the diagram, 20.8. Again, circle our answer. And just to show you, we could have found the hypotenuse first with cosine, but if we wanted to find the opposite, we have to use tan. So now let's find the opposite, or the hypotenuse, using cosine. The reason why we want to find the hypotenuse using cosine is because 12 is much more accurate and 20.8 has been rounded. So let's find the hypotenuse with cosine. So cos theta equals, from SOHCAHTOA above, ADJ over HYP. So we can say cos 60 equals the adjacent 12 over the hypotenuse. Now, if you go back in the videos, you can more carefully watch the theory, but if we simply times both sides by the hypotenuse and divide both sides by cos 60, we end up with hypotenuse equals 12 over cos 60. So if you have any difficulty with that, for example, 6 equals, 3 equals 6 over 2. Can I switch the 2 and the 3? Let's find out. Is 2 equal to 6 over 3? Absolutely. Cross multiplication. Switch the 2 and the 3. Simply timesing both sides by 2 and dividing both sides by 3. Either way, we're going to type this into our calculator. 12 divided by cos 60 equals 24. So we can say hypotenuse equals 24. We can circle our answer, and we can put that in the diagram near the hypotenuse. 24. Circle our answer. So for example, again, we could check with Pythag, but we are good. And now we want to find the other angle. So I'm going to identify that with theta in red in the diagram. Then I'm going to make sure I cross out OPP and cross out ADJ and replace OPP with ADJ. And replace ADJ with OPP because now they have switched. So notice 20.8 is rounded. 12 is a perfect number, and so is 24. So I want to use those numbers. So I want to use the opposite and the hypotenuse. Who uses the opposite and the hypotenuse? Well, we look at SOHCAHTOA and we realize that sine uses that information. So I can say sine theta equals opposite over hypotenuse. So we can then therefore substitute. So we have sine theta equals the opposite of theta is 12, and the hypotenuse is still 24. We can find theta by doing the inverse process. Sine -1, open bracket, 12 over 24, or simply 1/2, or simply 0.5, all the same. So on the calculator, if I press second sine 0.5, or 12 over 24, I'm going to get theta equals 30. Circle my answer. I'm going to put an arrow to theta in the diagram, 30 degrees, and circle my answer. So I'm going to check my answer in my head. 30 plus 60 plus 90 is 180. So we know that we're all correct. Okay, number 6. So notice the triangle kind of looks funny. Don't care. I'm going to draw it normally. And again, remember, I don't really care about the dimensions to scale. As long as the numbers are correct, that's all we mind. So it says solve for theta, the hypotenuse, and the other angle. So let's start out by finding the hypotenuse. So who uses the hypotenuse? Well, we could use sine, so, or cos. So let's use sine for fun. So sine theta equals opposite over hypotenuse. So I can identify my diagram. Opposite of the angle is OPP. Adjacent of the angle is ADJ. And the hypotenuse is always HYP. So we can substitute into the formula. So we have sine of theta equals opposite 12 over the hypotenuse, HYP. Oh wait, we're stuck. We have theta and the hypotenuse to look for. We can't use this yet. So again, we have to choose the part of SOHCAHTOA that has 2 pieces of information that we have and 1 piece that we want. So what I'm going to do is lightly cross it out. I'm not going to scribble it or erase it. I want to see it in the future. I want to go, look, I tried this. It didn't work. I want to remember when I'm studying my stuff that sometimes things don't work, and I have to more carefully choose what I want to do. So we have the opposite and the adjacent. Who uses that? Well, tan. So we have to start by finding theta. So let's use tan. So tan theta equals opposite over adjacent. Then we can substitute into the formula. Tan theta equals the opposite, 12, over the adjacent, 5. And we can find theta by doing the inverse process. theta equals tan negative 1, open bracket that, 12 over 5. And on the calculator, we can do second tan, 12 over 5 equals, and we're going to get theta equals 67.4 degrees. Circle our answer, and I'm going to put an arrow to theta in the diagram representing that that angle is 67.4 degrees. Circle our answer. Now, just for fun, the question says to use trig to find all that stuff. But I just did question 4 and 5 doing that trig. So do I just want to keep doing the same thing over and over again? No. I know how to do that process. I'm going to study how to do that process. But I'm going to be very lazy, and we're just going to do Pythag to find it. So let's go for a squared plus b squared equals c squared. Now remember, if they tell you you have to use trig, you have to use trig. But let's not. So 5 squared plus 13 squared equals c squared. 5 squared is 25. Excuse me, 12 squared. I'm going to erase, I'm going to cross out the 13 and say 12 squared. Excuse me. 5 squared is 25. 12 squared is 144. Therefore, 25 plus 144 is 169, equaling c squared. If I square root both sides, we know c equals 13. Circle our answer and put it in the diagram, 13. Again, it told us to find the other angle using trig. But couldn't I just add up all the angles and then do 180 minus? Yes, I could, but one of the angles is 90, so I know the other two angles add up to 90, so I can simply just do 90 minus the other angle, 67.4, and 90 minus that equals 22.6 degrees, and I can put that in the diagram, 22.6 degrees. Notice I circle my found information. So if I ever have a question or I want to redo a question, I just redraw the diagram exactly as it is without any of the circled answers. Then I retry the question without looking at my notes and then see if it works out. All right, a totem pole is 20 feet high. I'm going to draw the laziest totem pole and call it 20. So, and we have feet, so I'm going to put feet in the diagram. Okay, cast a shadow of 7 feet. So where is the shadow? Well, the shadow is on the ground. And we're obviously doing right angle trigonometry, so I'm going to make a right angle, and I'm going to make a right angle triangle. So it says find the angle of elevation of the sun. So we now want to find the angle of elevation. So we know that, let's say I have a Z. That might be a backward Z. Elevation is here and depression is here. Even if it's drawn this way, elevation is here and depression is here. So where is elevation in the diagram? I could identify it with an E. Good, so there is the angle of elevation. So, in order to find this angle, I need to use the part of SOHCAHTOA that I have, and I have the opposite and the adjacent side. So, I can say tan theta, because I'm using tan, I have the opposite and the adjacent, equals OPP over ADJ. So my angle is E, so tan E representing the angle of elevation equals the opposite, 20, over the adjacent, 7. Therefore, E equals tan negative 1, 20 over 7. So on my calculator, second tan, 20 divided by 7, equals 70.7 degrees. E equals 70.7 degrees. Circle my answer and put an arrow to it in the diagram and say 70.7 degrees. Now notice my triangle is not to scale. I forgot to name this question number 7, excuse me. Notice my diagram is not to scale, so that doesn't look like 70.7 degrees. But if you drew a triangle with a height of 20 and a horizontal length of 7, you would find it to be exactly 70.7 degrees, like we did in question number 1. Okay, number 8. So the angle of depression from a building is 30 degrees to a person standing 50 yards from the base of the building. So I'm going to draw a little lazy building, and the building is 50 yards from a person. I'm going to represent that person by a dot, and I'm going to say yards. So it says the angle of depression. So I'm going to draw my Z again, and elevation is the bottom and depression is at the top. So where on earth is the angle of depression in this diagram? Well, I'm going to draw the hypotenuse. Then I'm going to make a tiny little bit of a Z and know that depression is there. And what we know is that depression and elevation are the same. Angle E equals angle D. They are the same by alternate interior angles. So that is a rule that we're going to learn in parallel lines from last year. If you want any help on those rules, please feel free to check out Circles and Parallel Lines in grade 9. So if we're looking for the angle of depression, we're just simply, the angle of depression is equal to 30 degrees. Therefore, the elevation is also 30 degrees. It says find the height of the building. So I'm going to call that OPP, opposite of our angle, and we have the adjacent. So who uses the opposite and the adjacent from SOHCAHTOA? Tan. So we can say tan theta equals the opposite, OPP, divided by the adjacent, ADJ. Always writing the formula down first, looking at the formula, confirming with SOHCAHTOA. TOA, tan is opposite over adjacent. Perfect. So now we can substitute into the formula. So we have an angle 30. So tan of 30 equals the opposite, OPP, over the adjacent 50. So now we can cross multiply. We can, now we have 50 on the bottom, so we can simply times both sides by 50. 50 times 50. So on the calculator, 50 times tan 30 equals 28.9. So we have the opposite equaling 28.9, and we're going to get some units, yards. Circle your answer and put it in the diagram. So I'm going to put an arrow to the opposite and say 28.9 yards. Circle my answer in the diagram. Awesome. Okay, so let's solve for x. So question number 9 says solve for x. Let's draw that diagram. So we have a right angle triangle on top of some sort of a rectangle with an angle of 15 degrees and a vertical part of the rectangle being 2, and x is this full length. So how is x related to the diagram? Well, it is part of the opposite of this triangle. So, we have a hypotenuse of 10. Okay, so who uses the opposite and the hypotenuse? Well, sine. So let's say sine 15, notice I didn't write the formula down this time, equals the opposite. Now notice that's part of x, so I'm not going to say x. Opposite over the hypotenuse of 10. I have a 10 on the bottom, so I can times both sides by 10. Therefore, the opposite is going to equal 10 times sine 15. and we're going to get 2.59. Circle our answer. Now, I'm going to put it in the diagram, but I'm going to represent it by a red line. I just found this. So that is 2.59. Now, how on earth would I find x if that's that? Well, I'm going to represent in blue the part that's 2. So then x will simply equal the 2.59 that I figured out and the blue value, which is 2. So x is simply 4.59. Circle our answer. So there's going to be all sorts of idiosyncrasy types of questions that ask you things like that, and you might have to simply add or subtract a value. But this is all about right angle triangles, so it's all about identifying the right angle triangle, using SOHCAHTOA to find certain things that you're looking for, and then possibly doing a little idiosyncrasy. Okay, number 10, we have two triangles touching each other. So we have a right angle triangle with an angle of 30, and we have another right angle triangle with an angle of 60 and a side length of 5. And it says solve for x, the horizontal of the triangle on the left. So let's label the triangle. So the 5 is adjacent to the 60. The x is adjacent to the 30. But we need to find x. And we don't have enough information in that triangle to find x. So we need to find a shared piece of information. This part. That part is shared between both triangles. And it is opposite of the 60, and it's the hypotenuse of the 30. So we have to be careful. So we can start off with finding the red with the triangle on the right. So we're looking for the opposite. We have the adjacent, so we can say tan 60 equals the opposite, we don't know, over the adjacent 5. We can simply times both sides by 5. 5 over 5 is 1, cross it off. Therefore, the opposite equals 5 tan 60, which is 8.66. Circle your answer, put it in the diagram. 8.66, circle your answer. Now we need to use the other triangle. So now we're going to use the triangle on the left. So now, again, we're looking for x, which is the adjacent to 30, and we have the hypotenuse now. Who uses the adjacent and the hypotenuse? Cosine. So we can say cosine 30 equals adjacent ADJ, which is x, over the hypotenuse 8.66. So we can simply times both sides by 8.66 and cancel, and 8.66 times cos 30, the adjacent ADJ, equals 7.5. Therefore, x equals 7.5. Circle our answer, put it in the diagram, and circle your answer. Great. So again, in the last question, you might have to do some sort of idiosyncrasy and add or subtract. And in this example, we have to use the idiosyncrasy. We have to figure out some information from one triangle to then therefore use that information to find information from the other triangle. All right. Number 11. So it says find sine theta and theta if cos theta equals 3 over 5. So let's write down our given information. Cos theta equals 3 over 5. And we know we're talking about right angle triangles, so we're just going to start by doing that. Let's identify theta and our right angle. So it says find sine theta and theta. So let's start by saying sine theta equals opposite over hypotenuse from SOHCAHTOA. So what information do we need? Well, first of all, let's take a look at the given information. Cos theta equals 3 over 5. So from SOHCAHTOA, Ka, we know that the 3 is the adjacent and the 5 is the hypotenuse. So we can say 3 and 5. Notice that's not found information, it's given, so I'm not going to circle it in the diagram. So it's asking for sine theta. Well, sine theta equals the opposite. We don't have the opposite. We need to find it. In order to do that, we have to use trig. Well, we could use trig to find theta, then find the opposite, but let's just use Pythag. So a squared plus b squared equals c squared. And 3 squared plus b squared, we don't know, is 5 squared. 3 squared is 9. 5 squared is 25. If we subtract 9 from both sides, b equals 16. B squared equals 16, excuse me. If we square root both sides, b equals 4. I can circle my answer and put that in the diagram. So I'm going to label opposite, adjacent, and hypotenuse. So then, therefore, top right, sine theta is then equal to the opposite, 4 over the hypotenuse, 5. Circle our answer. That is what sine theta is equal to. So using cos information to have sine information, or we could find tan information. But now let's find theta. So using the circled information, theta will then therefore equal sine negative 1, open bracket, 4 over 5. And the sine negative 1, second sine of 4 over 5 is equal to 53.1 degrees. Theta equals 53.1 degrees. Circle my answer and put it in the diagram. 53.1 degrees. Awesome. So using information from given to find other information. Okay, so let's go on to 11b. So this time it says find cos theta and theta if tan equals 1.25. So let's write down that given information. Tan theta equals 1.25. Now again, we know we're working on right angle triangles, so I'm going to draw a triangle and identify theta and identify the hypotenuse, the opposite, and the adjacent. So tan theta is equal to 1.25. Let's write that down again. Tan theta equals 1.25. Excuse me, 1.25. Now, we need a fraction of side length. Sure, I could just find theta using the tan negative 1. Why don't we do that right away? Theta equals tan negative 1 of the decimal, don't care. Theta equals, so on the calculator, second tan of 1.25 equals 51.3 degrees. 51.3 degrees. Circle our answer. Okay, but we found theta, but now we have to find cos theta. So I'm going to start by at the top right. Cos theta equals adjacent over hypotenuse. So we can substitute into the formula. So we have cos theta equals, well, we don't know the adjacent and we don't know the hypotenuse. So we have to keep using tan. So down below, I'm going to write down my tan definition again. Tan theta equals, now what is 1.25? Well, I'm going to write that off to the right. 1.25 equals, well, that's just 1, and 0.25 is a quarter, so 1 1/4. And if I times the bottom by the left and add the top, I get 5 over 4. Which means tan theta is equal to 5 over 4. On my calculator, I can check that. 5 divided by 4 equals 1.25. Perfect. So that means that this is my adjacent, and this, excuse me, TOA, that's my opposite. Again, top right-hand corner, we have TOA, which tan theta is equal to the opposite, OPP, over the adjacent. So we can label the triangle. We have an opposite of 5, circle it. We have an adjacent of 4, circle it. So now, top right, we can start filling in information for cos theta. The adjacent to our angle is 4, but we need the hypotenuse. How are we going to find that? Well, we're going to have to use Pythag again. So we can say a squared plus b squared equals c squared. Then we can substitute. So we have a being 4, 4 squared. B is 5, 5 squared equals the hypotenuse c squared. 4 squared is 16. 5 squared is 25. 16 plus 25 is 41. Therefore, 41 equals c squared. Square root both sides. And c equals root 41. And some people like to give the exact answer. C equals 6.4. Circle our answer. Put that in the diagram. So that's our hypotenuse. 6.4. Circle our answer in the diagram. So then back to the right. Cos theta is therefore equal to 4 over, I like exact values, square root 41. You could have said 4 over 6.4. So again, finding information from other given information using trig and Pythag and SOHCAHTOA. Okay, so we have question number 12. It says sine 30 equals sine 30 degrees equals cos of x degrees. And we have to solve for x. So who knows what to do? But what we could do is we could draw a triangle with an angle of 30 degrees and label it opposite, adjacent, and hypotenuse. Now, what is sine 30? Well, sine 30 degrees is equal to the opposite of the 30, OPP, over the hypotenuse. Now, this question is very interesting, so I'm going to actually use letters. I'm going to use O, I'm going to use A, and I'm going to use H. Therefore, sine 30 is then therefore equal to O over H. Now, we have to figure out what cos of, if sine 30 equals cos of x at the top there, well, we need to figure out what x is. So, I'm just going to tell you because it's just so weird but so easy. So, what is equal to O over H? Well, we know sine 30 is equal to O over H. But how could we get something equal to O over H, where cos x would equal that? Well, in order for that to happen, we just have to say cos of 60. Cos of 60 degrees. And because it was cos of x, we therefore know x equals 60 degrees. The reason why we know this is because in this right angle triangle, we have an angle of 30, therefore we have an angle of 60. And what would the cos of 60 equal? The cos of 60 would equal simply the adjacent of the 60, I'm going to label the triangle, adjacent of the 60, excuse me, yes, adjacent over the hypotenuse, HYP. Therefore, I can say cos of 60, excuse me, cos of 60 is therefore equal to the letters that we assigned. So the adjacent is O and the hypotenuse is H. Now we know that these two things are equal to each other, therefore we know the angle X is simply 60. Okay, 12b, it says cos of 0 degrees equals sine of x degrees. So in the last question, we learned that the cos of an angle is equal to sine of 90 minus that angle. A very simple formula. And the reverse is also true. Sine of theta equals cos of 90 minus theta. So above in 12a, 90 minus 30 was equal to 60. Therefore, x was 60 in the last question. Therefore, we just have to do 90 minus 0 equals 90. Therefore, x is simply 90 degrees. And you can simply check that on the calculator. Cos of 0 equals 1, and sine of 90 also equals 1. That is a very interesting formula, very serious little idiosyncrasy, much more theoretical, and very useful in the future. All right, we have 13a. So we have a triangle embedded in another triangle. So I'm going to draw the bigger triangle and the smaller triangle inside. I'm going to identify both right angles. And the vertical of the big is 12, and the vertical of the small is x, and the horizontal of the small is 3, and the horizontal of the large is 6. And theta is at the bottom right-hand corner. So it says solve for x, tan theta, and theta. So we can just simply use similar triangles. So let's draw both triangles. So we have a large triangle with a side length of 6 and 12 and theta. And we have a smaller triangle with side lengths of x, theta, and 3. They both are right angle triangles. So because these are similar triangles, we can say something over something equals something over something else. So let's go for x over 3 equals 12 over 6. Keep in mind, I could have done it in so many different ways. I could have done x over 12 equals 3 over 6, and multiple different ways. So we're not going to do that. Let's do the one on the left. So I have a 3 on the bottom. I can simply times both sides by 3. And x will simply equal 12 times 3 is 36, divided by 6 is 6, or I could have done 12 divided by 6 is 2, times 3 equals 6 anyways. So we know that x is 6. I'm going to put that in the diagram in both locations and circle my answer. Good. So we found x using similar triangles, using proportions. There is going to be an over equals over principle, whereby something is to something as something is to something else, allowing us to solve triangles using similar triangles or proportions from grade 8. And then it's asking for tan theta. So what's the tan theta? Well, we know that tan theta is the opposite 12 over the adjacent 6. Now we'll simplify that. Tan theta will therefore 12 divided by 6 is 2. Would it matter if we use the smaller triangle? Let's try. Tan theta equals the opposite 6 over the adjacent 3. 6 divided by 3 is 2. Therefore, tan theta equals 2. Of course, it has to be. Tan theta doesn't mind how big the triangle is. Tan theta is just simply a ratio of how big the opposite is to the adjacent. So if the triangles are similar, they will obviously have the same tan ratio. Okay, so now we're going to find theta. So theta therefore equals tan negative 1 of 2. And theta therefore equals, on the calculator, second tan of 2. We get 63.4 degrees. Circle our answer, and we can put that in the diagram. Both thetas, all of them, are all 63.4 degrees. Okay, 13b. So very similar question to 13a. So we have a vertical of 12 on the big and a vertical of 2 on the small. We can identify theta. The small horizontal is x, and the horizontal part of the big triangle is x, and the small part is 3. So let's draw those separately. So if we draw our triangles separately, identify theta. Now the vertical of the big is 12. The vertical of the small is 2. The horizontal of the small is 3. And now look at this. The horizontal of the big is not x, it's not 3, it's x plus 3. So again, we can use over equals over to solve this, and I like to put variables on the top. So I'm going to say big horizontal over small horizontal equals big vertical over small vertical. As long as you stay consistent, that setup will be okay. So let's start by doing things. So x plus 3 over 3 equals 12 divided by 2 is 6. I have a 3 on the bottom. I can simply times both sides by 3. 3 over 3 is 1. Therefore, I can cancel, and x plus 3 equals 18. And I can subtract 3 from both sides. Therefore, x equals 15. And we've solved for x. We can put that in the diagram, 15. X is 15. So now it's saying to find tan theta. So I'm going to use the small triangle because why bother using the big one? We learned in the last one it doesn't matter. So if we use the small triangle, tan of theta is simply equal to 2 over 3. We don't even have to use the x that we just figured out. Circle our answer. Therefore, theta equals tan negative 1 of 2/3. Therefore, theta equals second tan 2 over 3, 33.7 degrees, and put it in the diagram. Excuse me, 33.7 degrees. So notice again, I didn't write down the formula before I substituted into tan. We want to get more and more comfortable using SOHCAHTOA and just substituting straight into it. So this was a nice little idiosyncrasy where we had to remember that the horizontal length wasn't x of the big triangle, it was x plus 3. Be very careful. Okay, sorry about the order of the questions, 13.5a. So let's take this gigantic right angle triangle with an angle of 30 and a hypotenuse of 20 and a right angle and another line coming down like that, which is 15 with an angle of 41.8 degrees. Okay, so we're looking for x, this bit of this triangle here. Well, so what the first thing we're going to do is we're going to separate the triangles. So we're going to draw both right angle triangles, not the scalene triangle. So we have two right angle triangles, and the first one we have a hypotenuse of 20. Notice they're in exactly the same orientation, and an angle of 30. And then the other right angle triangle has a side length of 15 and an angle of 41.8. So I'm going to highlight in red the part that we're looking for, which is only part of this. So we're going to need to find the yellow bit on the triangle on the right and then do something with that. So let's find both adjacents. So we're going to use cosine. So for the triangle, of the two triangles on the right, the triangle on the left, cos 30 cos 30 equals ADJ over the hypotenuse 20. And again, I'm just going to set it up off to the right as well. Cos 41.8 equals ADJ over 15. And earlier in our notes, we've learned that if we're on the equation if we have something on the denominator, we're simply just going to times both sides by that denominator. 20 times 20, cancel. And then 20 cos 30 is going to be 17.3. So we know that the adjacent is equal to 17.3. Circle my answer. Put it in the diagram. 17.3. Circle my answer. Okay, and then the other one, we're going to times both sides by 15. I'll do that in blue because I've squished it a little bit. And then therefore ADJ is equal to 15 cos 41.8, and we're going to get 11.1. And then we know that x, this length here, x, is just equal to the big length, 17.3, minus the small length, 11.1. And 17.3 minus 11.1, should be able to do that in my head, but 6.2, whatever it is. It might be meters, it might be kilometers, who knows? But x is 6.2. So that question wasn't as obvious as how the triangles share information, like in some of the previous questions, whereby it's much more obvious. So very helpful to take your triangle and do two separate triangles in exactly the same orientation, labeling them very carefully, then thinking logically about which part they share and how to figure out what we're looking for. Okay, so just to let you know, the last question I called 13.5a, we're now calling 13c. Sorry about that. It was an order problem and it compounded. So forget that. So now we're going to do 13d. So I'm going to start off by drawing this gigantic right angle triangle, way bigger than you think. Put in the right angle, put in x, put in 30, put a line down like this, call this one 41.8, and this time this part is 20. And we have to find x. So again, we're going to draw the triangle separately. Notice not perfectly, but in exactly the same orientation. So we've got 30. They both share x. And then we have 41.8 in the right triangle. Pardon the pun. Great. So we now know that part of something is 20. So what we want to do is we want to create another variable. Like we're looking for x, but we don't have enough information to find x. So we need another variable. So I'm going to put y right here, which is this length right here. Therefore, this horizontal will just simply be 20 plus y. Way more difficult. This is a very advanced question. I would only do it if you're doing hard math. So, because it's going to take so much algebra, I'm going to start on the margin even though I'm working on the two triangles off to the right. So, we have tan information because we have opposites and adjacents. So I can say tan 30 equals opposite, which is x, over the adjacent, 20 plus y. Then off to the right, I can do tan 41.8 equals x over y. So there's going to be a ton of different ways to do these questions. Now, it's better to do it in exact value, but I would rather not. So I'm just going to figure out what tan 30 is on the calculator and put it there. 0.577 equals x over 20 plus y. And the tan of 41.8 is 0.894 equals x over y. So again, so many different ways to do this, but I'm going to cross multiply. So if you don't know how to cross multiply, check out my videos on grade 8 on cross multiplication, but I'm going to figure out what x is, for example, on the equation on the right. So I'm going to times both sides by y. So 0.894y equals x. Then I'm going to cross multiply on the left-hand side. So I have 0.577 open bracket 20 plus y equals x. So this is going to happen sometimes. You should obviously be writing a little bit smaller than I am, but I'm going to shrink my work a tad. Good, and then I'm going to continue. So I'm going to distribute in here, and 0.577 times 20 is this. So we're going to get 11.54 plus 0.577y equals x. And we know that from this equation over on the right, x is equal to that, so I can put that in there. So we know 11.54 plus 0.577y equals 0.894y. Then I can simply subtract 0.577y from both sides, or simply bring it over, minus 0.577y. And 0.894 minus 0.577 is equal to 0.317. So we have 11.54 equals 0.317y. And we can divide both sides by 0.317, simply cross multiplying it down to the other side. Therefore, mirroring the equation, we know y is equal to 11.54 divided by 0.317, and we're going to get 36.4. Circle our partial answer. Now keep in mind that we're looking for x. So now I'm going to use this equation up here to find x. So I'm going to shrink my work up again, and then I'm going to rewrite it. So I'm just going to shrink the work that I've just done so I don't accidentally shrink other stuff too much. So again, taking that function, 0.894y equals x. And then taking the y value and substituting it, so 0.894 open bracket 36.4, the y value equals x, the y value that we just got a second ago. And if I take that and I multiply 0.894 times 36.4, I'm going to get x equals 32.5. Circle my answer. Put it in the diagram, 32.5, circle it, put it in the other diagram, 32.5, circle it, put it in the other diagram, 32.5, circle it, just so we have a nice big logical answer of all of our different things. Yes, if y is about 36, then x is about 32 based on a whole bunch of logic. Great, so again, that question is so much more difficult than 13C, or what I called 13.5a, excuse me, just the question right before. So that question just very difficult. It will probably only be a homework question unless you're in more advanced math. You might see something like that on a test. All right, number 14. So we have a triangle with an angle of 48, a side length of 8, another side length of 15, and x. And we are looking for x in degrees, so solve for x. So notice this isn't a right angle triangle, so we need to make one by drawing a vertical line straight down, making two right angles. Therefore, we have two right angle triangles, and the length, the vertical length that I drew in red, is the length that is shared. So notice it's both the opposite of the 48 and the opposite of the x. So starting off with the 48, we have the hypotenuse, and the x, where we have the hypotenuse. So who uses, let's start off with the 48. So we're looking for the opposite. We have the hypotenuse. So Katoa says we have to use sine. So we can say sine of 48 equals opposite. We don't have it, over the hypotenuse, 8. Now we have an 8 on the bottom, so we can times both sides by 8 and cancel. Therefore, the opposite is equal to 8. sine 48. So we're going to get 5.9. So opposite equals 5.9. Circle our answer, put it in the diagram, circle your answer. So we're now going to use sine again. So sine of x is equal to the opposite that we just found, 5.9, over the hypotenuse, 15. Now we need to find the angle. So x equals sine -1, open bracket, that. You could do the division first and know what it is, but I would prefer this. So second sine, 5.9 divided by 15 equals x equals 23.16 degrees. And I can put an arrow to x and say 23.16 degrees. Now, some of you should be thinking, but you rounded that number to be 5.9. The opposite in blue, OPP, was actually 5.945. So technically I rounded to 1 decimal. Let's see how much that would have affected our answer. So off to the right, x equals sine -1, open bracket, 5.945 over 15. And this time I'm going to sine inverse that. So second sine, 5.945 divided by 15, x equals 23.35 degrees. So quite a fair bit. So notice, if you have to, for example, round a degree to 1 decimal place, well then if we want, we must keep like 4 decimal places, at least 3 or 4. So just keep that in mind. They may just be asking for a certain number of decimal places, but you want to keep a lot more and then eventually write the final answer. So the final answer, if we rounded properly, would have been 23.4 degrees, not the initial 23.2 that we had thought with accidentally rounding too early. So this triangle is another example of using one of the triangles to figure out information for the other triangle. All right, number 15. So we have another triangle with side lengths of 5, an angle of 65 degrees. We're looking for x, and this time the whole bottom is 10. So again, we have to draw a vertical line and make 2 right angle triangles. But this length is no longer 10. Well, the whole thing is 10, but we don't know what the parts are yet. So we need to do something. So let's first find that vertical red, the part that's shared. So how is it related? So the 5 is the hypotenuse, and the red is the opposite to both the 65 and the x, so that's nice. So who uses the opposite and the hypotenuse? Sine. So we can say sine 65 equals the opposite over 5. Now we have a 5 on the bottom, so we can times both sides by 5. And therefore the opposite will equal 5 times sine 65. And we're going to get 4.53. Circle our answer, put it in the diagram. And circle it. Okay, so we have that. We need to find x though. Now, we definitely have opposite information and adjacent information for x. So let's start by using tan. So tan x equals the opposite, 4.53, the opposite of x, over the adjacent, we don't know. We know part of it's 10. So therefore, we need to separately find the horizontal of the triangle on the left in blue and the horizontal of the triangle on the right in yellow. So let's start off on the left. So on the left, let's find that. That is the adjacent side to both 65 and x. So let's start on the triangle on the left. So we're looking for the adjacent. We have the hypotenuse, so that's going to be cosine. So cosine of 65 will equal to the adjacent, ADJ, over the hypotenuse 5. We have 5 on the bottom. We can times both sides by 5. And we can say cos 65, 5 times cos 65 equals, we can say adjacent equals 2.11. Okay, so I'm going to redraw this diagram. So we just found the part on the left, 2.11. We knew that the whole length was 10. So in order to find that little bit, we can just do 10 minus 2.11 equals 7.89. And we can put that in the diagram. 7.89, circle it, and we can put it in the other diagram near the yellow. 7.89, circle it. I forgot to circle the 2.11 in the diagram on the right. I forgot to put 2.11 in the diagram on the left and circle it. Great, so we know that's just 7.89, and we can therefore put it in for the adjacent. So tan x equals 4.53 over 7.89. Therefore, x will equal tan negative 1 of that, 4.53 over 7.89. Therefore, x equals second tan, 4.53 divided by 7.89, and we get x equals 29.86 degrees. Circle our answer and put it in the diagram. 29.86 degrees. Circle our answer. Notice all these different circles. Sometimes it would be helpful to possibly maybe circle it twice as our final answer, or maybe write it again. X equals 29.86 degrees. 1, 2, to decipher the difference between our circled partial answers, like the one right here that I forgot, and all the other partial answers, and this one final answer. So a little bit more difficult than the last question, but using parts of other triangles to help us solve using shared information from different triangles to find information about triangles. Okay, number 16. Find all the angles. So this time I'm just going to draw a gigantic diagram. We've got our right angle. We have an angle of 30 degrees. And then we've got another interesting looking right angle triangle. So I'm going to draw the vertical line first and make the right angle. Then I'm going to draw the angled line, then the line that meets up to it, and the right angle at that location. So I'm going to start off with this triangle right here on the left. So if this is 90 and the other angle is 30, we know that 180 degrees in a triangle. So I could say 30 plus 90 equals 120. Then I could do 180 minus 120 equals 60, and I know the angle is 60, but I'd rather just do 90 minus 30 equals 60. And I can put that in the diagram, 60 degrees. Okay, now I'm going to erase this red. Okay, now we can go from there. So we have that one being 60, and we therefore also know that this one is 60 degrees. The reason why we know that is because these are similar triangles. We have a gigantic triangle and we have a triangle on the inside. We know that this theta has to be equal to this theta by corresponding angles. Okay, so then we can continue. So I forgot to put one of the right angles in the diagram, this one right here. I'm going to redo that one in red so you know which one I just put in. Okay, so if that's 90 degrees, then this one has to be 30 degrees. In blue, if this is 90, then this is 90 as well. In red again, if this is 90 and this is 60, this is 30. In blue, if this is 30 and this is 90, this is 60. Then we have angles on a line. If we have a 90 and we have a 60, we know that angles on a line add to get 180. So 90 plus 60 equals 150, and 180 minus 150 equals 30. So we know that this angle is 30. I also could have just used the fact that this is also a 90 because this is a 90, and if one part is 30, the other part is 60. Then my last angle, bottom right in red, if this is 30, this is 60. So be very comfortable using parts of information to figure out other parts of the diagrams, especially if you're going to be doing more advanced math or advanced science like physics in the future. All right, 17. So I'm going to start by drawing the diagram. So we have a river and we have a cliff on the other side. Who knows how far back it goes? We have one person here represented by a person and one person here represented by a person. Now from the person on the right straight across is 50 and the height of the cliff is x. And there is a hypotenuse from the person to the height of the cliff, meaning that this is awkwardly a right angle. And I'm going to start by taking that triangle and drawing it first. Great. So then there's this other triangle with a hypotenuse in blue from the person to the top of the cliff, represented by y, and a right angle right here. And I can draw that triangle on the left. And I can call that y, I can put a right angle, and I know that they share a side, and I'm going to highlight that in red, the side that they share. So, we need to find information. So, one more piece of information in the diagram. This angle right here is 60 degrees, which means that this angle down here is 60 degrees. So we need to find x and y. So let's first find x. So in the diagram on the right, we can find x. That is the opposite of the 60. So who uses the opposite? We can say tan 60 equals opposite x over the adjacent 50. We can times those sides by 50. Therefore, x equals 50 tan 60. Therefore, x equals 86.6. Excuse me, 86.6. The question is in meters, so our answer is meters. Put that in the diagram. X equals 86.6 meters. Nice logic check. Seems realistic for the height of a cliff if we have that angle and that width of the river. So that was useful. Now we need the shared part. The red part of both diagrams are equal to each other. So let's start on the diagram on the right. So we're trying to find the hypotenuse. We have the adjacent. Let's use cosine. So cosine of 60 equals the adjacent 50 over the hypotenuse, HYP. I'm going to identify HYP in the diagram. Then remember we have to cross multiply. So HYP is simply equal to 50 over cos 60. Again, remember that if 3 equals 6 over 2, we can switch the 3 and the 2. Is 3 equal to 6 divided by 2? Yes. Is 2 equal to 6 divided by 3? Yes. Cross multiplication. Excuse me, 60. I'm missing a 60. I put that in red. Therefore, the hypotenuse is just 50 divided by cos 60, and that's going to equal 100. The hypotenuse equals 100. Circle our answer. Put it in the diagram twice. So it's this hypotenuse and it's this side. So now we need to find y. So, oh, we're missing an angle. I'm putting in blue in the diagram. We have 55, and again, 55. So we have the opposite. We're looking for the hypotenuse. We're going to use sine. So we can say sine 55 equals the opposite, 100, over the hypotenuse. We can cross multiply. Therefore, the hypotenuse is equal to 100 over sine 55. And on the calculator, 100 divided by sine 55 is simply 122. The hypotenuse, I'm going to call it y, equals 122.1 meters. Put it in the diagram, 122.1, and put it in the big diagram, 122.1. So a nice logic check. If this is 50, if the width of the river is 50, and this angle is 60, and this other angle is 55, yes, the height of the cliff should be about 86.6, and the distance from the other person to the top of the cliff should be approximately 122.1. Great. So again, using different parts of information to figure out what's shared, and then figuring out how you can use that shared information to find information from other triangles. Okay, number 18. So this diagram is interesting. I'm going to draw a gigantic. So we have our first triangle with a right angle and an angle of 40 degrees. Then we have another triangle off to the right, a right angle triangle with an angle of 70 degrees and a side length of 21. And the other triangle has a side length of 15, and we're looking for x. So this question, some people think that this middle triangle is a right angle triangle, and they just assume it and guess, and it's absolutely not. So how on earth are we going to find this? Well, first things first is we're going to think outside of the box. And we're going to draw this line and that line meeting at a right angle, a method called extend the lines. So in order to do this, we have to find blue and blue, and then do a subtraction to find this. Then we have to do yellow and yellow and add them up to find this. Then we just have to do Pythag to find x. And I'm not going to do that. So use all the skills that you have from the past to figure out exactly what I just said to do. Finding in red this part and that part to find that part, and this part and this part to find that part, then doing Pythag to find that part. Think outside the box. Okay, 19A, find the area. So let's draw this funny looking triangle. We have an angle of 23 on the bottom left and an angle of 42 on the bottom right, and we have a hypotenuse of 10 on the right. So we need to find the area. So let's start by writing the formula for area. A equals base times height divided by 2. So do we have any of this information? Absolutely not. So I'm going to identify the base as B, and I identify the height. I'm going to draw a vertical line and call it the height. So we need to find those things. So I'm going to start by drawing my triangles separately. So we have 23 and H in both diagrams, and then the base is shared, and we have 42 and 10. So we have to start by using information from the triangle that we have to work towards what we're looking for. So let's start on the diagram on the far right. Let's try and find H, which is the opposite. The height is the opposite. So we have the 10, so we can say sine 42 equals the opposite called h, careful, over the hypotenuse, hyp, which is 10. Don't get confused with h for the height of the triangle and hypotenuse, the hypotenuse of the triangle. So we can times those sides by 10, and 10 sine 42 is simply 6.69. So h, my height, is 6.69. Circle my answer and put it in the diagram. 6.69 and circle it. Okay, so we have our height. So we can put that into the formula for h, for the area, but we need the base. Okay, well, then we need to find the adjacent. I'm going to do that in red, excuse me. We need to find the adjacent of the triangle on the right and the adjacent of the triangle on the left, and then add them together. So let's start with the adjacent on the right. So we have the hypotenuse, we're looking for the adjacent, that's cosine. So cosine 42 equals the adjacent, 80j, over the hypotenuse 10, times both sides by 10, and the adjacent will simply equal 10 cos 42, which is equal to 7.43. Circle our answer, put it in the diagram. I'm going to put it in red. So this part, excuse me, I'm going to put it in red. So this part is 7.43, but only from here to here. We now need to find this adjacent. Excuse me, that's a funny looking arrow. We now need to find this adjacent. Again, using cosine. So let's say cosine 23 equals the adjacent, what we're looking for, over the hypotenuse. Oh wait, I don't have the hypotenuse of that triangle. Oh, can't use cosine. Okay, so what do we have? Well, I'm going to identify the height in both of the small triangles. So the height was 6.69, as we figured out. Again, 6.69, that we figured out from here. So we have to use tan. So let's say tan 23 equals the opposite. Now the opposite is the height value, which is 6.69, over the adjacent 80j. We know we're looking for the thing on the bottom. We switch, cross multiplying, 6.69 over tan 23. And we get the adjacent equaling 15.76. I'm going to put that in the big diagram. So that's this part, 15.76, going from there to there. Now I can simply find the whole base length. B equals 15.76 plus 7.43. And that will equal B equals 23.19. Circle our answer. Now we can go back to the area formula and say A equals the base value that we got, 23.19, times the height, 6.69, divided by 2. Therefore, A equals 23.19 times 6.69 divided by 2, and we get an area of 77.6. Now, we weren't actually given any units, so I'm just going to give it some units for fun. Centimeters squared. Remember, area is squared. So notice, we had to find the area, so we wrote the area formula down. Then we realized we needed to find this height. So we drew both diagrams separately. Found all the information that we needed to using sine, cos, and tangent to eventually find the area. I'm just going to erase all that blue so you have this better for the solutions. Okay, 19 14b, again, find the area. Let's draw this triangle. So we have an isosceles triangle with side lengths of 10 centimeters and an angle of 42 degrees. So again, we need to cut this triangle in half to find the vertical, and not again cut it in half. This one we're cutting in half. The last one we didn't cut in half, we just cut it. But we always cut it vertically, so we have two right angle triangles. So again, I'm going to draw my triangles separately. And we have a side length of 10 and a side length of 10, and this was an isosceles triangle. So if I take that 42 and cut it, I'm actually going to get 21 and 21. But be careful, it's not always exactly half. It's only exactly half when it is exactly half, for example, like this one with an isosceles triangle. So we need to find that height. So how on earth are we going to find that height? We don't have enough information. Oh, do we? Oh, we do. Excuse me, we do. So we need to find this length. So how is that related? Well, it's the adjacent to the 21, and we have the hypotenuse. Who uses the adjacent and the hypotenuse? Cosine. So we can say cosine 21 equals adjacent ADJ over 10. So we can simply times both sides by 10 and cancel. Therefore, ADJ, or the height, is equal to 10 times cos of 21, and we're going to get 9.34 centimeters. Circle your answer. Let's put that in the diagram. So first I'm going to put it in the small diagrams on the right, 9.34. Then I'm going to put it on the big diagram on the left, 9.34. So again, I should have from the beginning wrote down the formula that we were looking for. A equals base times height divided by 2. So we now have the height, but we need the base. How are we going to find the base? Well, that base is in blue here, which is just this and this. So let's use this triangle. So we're looking for the opposite. We have the hypotenuse. So that's going to be sine. So we can say sine of 21 equals the opposite over 10 times both sides by 10. And the opposite will therefore equal 10 sine 21. And that will be 3.58 centimeters. Circle our answer and put it in the diagram. So this part is 3.58. And this part is 3.58. Because of the diagrams on the right, if we just found the 3.58, then this is also 3.58 because it's an isosceles triangle and it's symmetrical. Okay, so if we find the full length of the base will equal 3.58 plus 3.58, or 3.58 times 2. And we're simply going to get 7.17. 7.17. Keep in mind that's a rounded answer. We're not too concerned. Centimeters. And now we can go into the area formula on the left. A equals. Notice I skipped a line to show that I did this up on the right first. So area equals my base, 7.17, times my height, 9.34, divided by 2. Therefore, my area is equal to 7.17 times 9.34 divided by 2 equals 33.47 centimeters squared. Our final answer, circle it twice. All right. Okay, number 20. So if a television set has a ratio of 4:3, I'm going to start by drawing a little 4:3 ratio with a 4 horizontal and a 3 vertical, because we know TVs are usually wider than they are vertical. Now it says find the area if the diagonal is actually 40. So let's draw a bigger TV with an actual diagonal of 40. And we're going to hold the same ratio, 4 to 3. Well, first things first, we need to find the diagonal of the small. So we know a squared plus b squared equals c squared. And we know 3 squared plus 4 squared. Order doesn't matter, except c is always the hypotenuse. 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, equals c squared. And if we square root both sides, c equals 5. Circle our answer, put it in the diagram. So that's 5. Now we need to ask ourselves, how many times bigger is 40 than 5? Well, 40 divided by 5, bigger divided by smaller, is simply equal to 8. Notice how I show that step. It's not because I don't know what 40 divided by 5 is. It's because I want to make sure that when I'm looking in my notes, I can clearly see it, that there's a division involved. And if it's harder numbers like decimals, I don't get worried. I just do exactly what I did before. So we know that it's a times 8. Therefore, 4 times 8 equals 32. We can put 32 on the horizontal and circle it. And then 3 times 8 is equal to 24. And we can put 24 on the vertical. And the area of the rectangle, A, equals length times width. Therefore, A equals 24 times 32. Therefore, A equals 768. And then we were given inches. I'm going to put that in the diagram. Therefore, our answer is inches squared. Great. So notice we didn't even use trig. I could have used trig. I could have found a bunch of angles and then did a bunch of stuff, but I just wanted to throw you off a little bit. Just because we're doing trig doesn't mean we have to use SOHCAHTOA all the time. We could be doing similar triangles, we could be doing ratios, we could be doing areas of triangles, or Pythagoras' theorem. Great, so we found the area of the television. Okay, so we have 21. A flat hill has a ratio of a horizontal length of 10 kilometers to a vertical length of 800 meters. And we're going to be driving our car up the hill. And our speed is 50 kilometers per hour. So notice, I have kilometers, I have meters, and I have kilometers per hour. I want to get everything into kilometers. So let's start by taking the 800 meters and converting it. So we need to cross off meters, we need to get to kilometers. There's 1,000 meters in 1 kilometer. And 800 times 1 divided by 1,000 is simply 0.8 kilometers. Circle our answer, cross out our information in the triangle, and say 0.8 kilometers. And circle our found information in the diagram. Okay, so again, yeah, we could use trig, but let's just do SOHCAHTOA. It'll be a lot simpler. So a squared plus b squared equals c squared. Then we have 10 squared plus 0.8 squared equals c squared. 10 squared is 100. 0.8 squared is 0.64. So it's 100.64 equals c squared. And we'll need to square root both sides. Therefore, c will equal the square root of 100.64. And c therefore equals 10.03. Circle our answer. Notice we need that 10.03. We need that second decimal. So now we're going to use it. So we know that we're wondering how long it's going to take to drive that up there. So we know our formula is speed equals distance over time. We have the speed, it's 50. We can put 50 in for speed. Our distance is 10.03. and our time is what we're looking for. We can cross multiply, as we've learned before. If we're looking for what's on the bottom, we can then therefore say t equals 10.03 divided by 50. I forgot to put 10.03 in the diagram. I'm going to put it there, 10.03 kilometers, and circle our answer. Okay, back down to the bottom right. T then therefore equals 10.03 divided by 50, and our time will be 0.2 hours to drive up that hill. Now that question was a little bit silly. I probably should have made the height of the hill a little bit more to make it not so almost identical to the horizontal, but all good. Sometimes you want to answer these questions in an English sentence. It would take 0.2 hours to drive up the hill. Period. Okay, question number 22. If the terminal arm of angle theta lies between the line 2y minus 3x equals 0 and the x-axis where x is greater than 0, determine the exact value of sine theta plus tan theta. So we'll come back to that. So first we need to graph this line. Now, we may have already learned y equals mx plus b or not, so we're going to do both ways. So, first of all, I can take this line, 2y minus 3x equals 0, and I can add 3x to both sides. Therefore, 2y will equal 3x. Then I can divide both sides by 2, and y equals 3 over 2x. And then I'm going to say plus 0, so it's in the y equals mx plus b format. So then I can draw that graph. Now it said when x is greater than 0, so I don't care. Now in my y equals mx plus b format, b is the y-intercept, 0. And 3 over 2 is the rise over run. Up 3, over 2, put a point. Draw the line, and identify theta. We're trying to find that theta. So I'm going to put more information in the diagram so we know we have a rise of 3 and we know we have a run of 2. So before we do that, keep in mind you could have just made a table of values x and y and then chose numbers like 0 and got 0 and 2 and got 3, etc. So, just keep that in mind. We can always graph stuff with a table of values if all else fails, or if you haven't learned y equals mx plus b yet. So, we can say that tan theta equals opposite over adjacent. Therefore, we can take that answer and put it into the question. For sine theta plus tan theta, that's 3 over 2. Now, what's sine theta? Well, we're going to have to do Pythag. So, if we take 2 squared plus 3 squared equals c squared, 2 squared is 4, 3 squared is 9, 4 plus 9 is 13 equals c squared. If I square root both sides, c equals root 13. If you're not comfortable with square roots, feel free to type that in the calculator. I'm going to put that in the diagram. Root 13. Therefore, sine theta would simply equal the opposite 3 over root 13. Then we can take that and put it back into the question. 3 over root 13. So now we're going to be adding fractions. We have a lowest common denominator of 2 root 13, simply multiplying them together. And we times the top and the bottom of the fraction on the left by 2, and the top and the bottom of the fraction on the right by root 13. And 2 times 3 is 6, and 3 times root 13 is just 3 root 13. And now we have a lowest common denominator of 2 root 13, and we can simply add the tops. 6 plus 3 root 13. Keep in mind, in Pre-Calculus 11, we're going to learn how to get rid of that root on the bottom, but that will be our final answer. of what sine theta plus tan theta is based on given information in a graph. Okay, question number 23 says draw 40 degrees north of east. So we start off by drawing a cross and identifying north, east, south, west. Now, we want to go north of east. So what we do is we say towards north from east. So this word, this little O of means from. So we start off facing east and we go 40 degrees this way. I'm going to erase the original red, and that's my angle. This angle is not only called 40 degrees north of east, we also call it, open bracket, east 40 degrees north, meaning from east 40 degrees towards north. So keep in mind, they can ask you both of those. They are very interesting. Different ways to write it. So circling in red at the top, we can write it that way, or red off to the right, we can write it that way. So just make sure you know which type your teacher is asking for and then use it. So 23B. So now we're going to do 30 degrees west of south, also known as south 30 degrees towards the west. So if I draw my cross and identify north, east, south, west, so 30 degrees from west to 30 degrees towards west. Excuse me, this one is difficult. 30 degrees towards west from south. So we start south, then we go 30 degrees that way. Excuse me. So I'm going to erase the initial red, and that's where the angle is. 30 degrees west of south, or from south 30 degrees towards the west. So two different ways we can write angles, both very useful. Usually they don't do this until grade 11, but may as well use it here. All right, 24A. So find the perimeter and area. So let's draw the diagram. So we have a half circle with a radius equaling 3 centimeters. So we want to first start by finding the area. So area equals pi r squared. Therefore, area equals pi times the radius 3 squared. Therefore, area equals 9 pi centimeters squared, or we can multiply 9 by pi. 9 times pi equals 28.27 centimeters squared. I'm going to circle both answers because both answers are good, but we now have to take our answers and divide them by 2. So area of half of the circle is equal to 28.27 over 2. Divided by 2, Therefore, the area of 1/2 of a circle is 14.14 centimeters squared. Now I'll find the perimeter. So the perimeter is going to be the diameter of the circle plus the circumference. The formula for circumference, C equals 2 pi r. Therefore, C equals 2 times pi times the radius 3. Therefore, C equals 6 pi centimeters. And 6 times pi is C equals 18.85 centimeters. So that's the circumference. Now I need to find the diameter. Well, the diameter is just twice the radius. So diameter equals 2 times 3. Therefore, the diameter equals 6. Circle our answer, and the full perimeter will equal the diameter 6 plus the circumference. But is it the full circumference? No, it's just half the circumference. So 18.85 over 2. I probably should have done that separately. So P equals 6 plus that 18.85 divided by 2, and we're going to get a perimeter of 15.4 centimeters. Interesting. Okay, 24B. Okay, so we have a little slice of Pac-Man with a radius of 5 centimeters and an angle here of 60 degrees. So we definitely used to have a full circle somehow, and then it looks like we've cut off an angle of 60 degrees. Well, how many 60 degrees are there in a circle? Well, 360 degrees divided by 60 degrees is 6. So we know that it's broken up into 6 equal parts. Therefore, we just need to find the area of the total and then do some more math. So A equals pi r squared. So A equals pi times 5 squared. And 5 squared is 25. And 25 times pi is going to be A equals 78.5 centimeters squared. Now that is the full area of the circle, but we don't want that much. So we only want 5/6 of it because we're looking for 5 parts of 6. So we're just going to times that by 5/6. We also could have separately divided by 6 and then times by 5. But let's just take that answer and times it by 5 over 6. And we're going to get equal to 65.4 centimeters squared. Circle that answer twice, a final answer. Okay, now the perimeter. Well, we're going to have to find the circumference. So C equals 2 pi r. Therefore, C equals 2 times pi times 5. And 2 times pi times 5 is 31.4 centimeters. Now that's the full circumference. But I'm going to outline in red, we only want 5/6 of that. So I'm going to times it by 5/6. Or again, you could have divided it by 6 to find a 6 and then times it by 5 parts. Times 5 over 6 equals 54.5 centimeters. Circle our partial answer. But the perimeter is going to be the circumference, or 5/6 of it, plus 2 more radiuses. I'm going to draw in blue. This radius and that radius. So the perimeter will in there equal 54.5 plus twice 5. 2 times 5 is 10. Therefore, P equals 64.5 centimeters. Circle our answer twice, and we have the area and the perimeter of that shape. Keep in mind, in Pre-Calculus 12, we're going to learn more advanced formulas to find things like the circumference of a not complete circle. All right, a wheel with a radius of 5. Question number 25. A wheel with a radius of 5 centimeters. Let's draw a circle. Let's give it a radius of 5 centimeters. Goes, I'm going to put an arrow. So this wheel is going to be turning a bunch of times. And it's going to go a total of 62.84 centimeters. Now, we're just wondering how many degrees did it turn? Question mark of degrees of turns. So we need to figure out how many times this wheel turned. So in order to do that, we just have to find the circumference and do a division. So let's find that circumference. So C equals 2 pi r. Therefore, C equals 2 times pi times 5. Therefore, C equals 31.4 centimeters. So the circumference of the wheel all the way around is 31.4. So if we want to figure out how many times it turned, we're just going to do bigger divided by smaller. 62.84 divided by 31.4 equals, it's 42. 1 second. 10 times pi is 31.42, 31.42. Let's get another decimal. So that means that 62.84 divided by 31.42 is equal to 2. Therefore, we know that it turned twice. 2 turns. Now, what's a turn worth? Well, how many degrees in a circle? Well, a full degree is 360 degrees. Therefore, we can cross off turns and say 360 degrees. And 2 times 360 is 720 degrees. Double circle, our final answer. So, we know that the angle is 720 degrees if we turn twice, if we have a radius of 5, and we go a distance of 62.84.